In this video, we will be studying volumes, specifically disk and washer method. So we're doing volumes of revolution. We're going to take curves and rotate it about X and Y axis and solve using the disk and wash method. So if you take a single curve, like Y is equal to f of X, right? And you rotate it about the X axis. So example, just basic simple curve. If I take uh, a curve like a straight line, right, between A and B. So the starting value is A, the ending value is B, and the rotation is about the x-axis, right? So if I rotate this about the x-axis, we get some kind of volume like this, right? Because we're rotating that curve, we get like a cone. So what formula do we use? The formula that I like to use is say volume is equal to integral of cross-sectional area A of x dx. Now, what is area? Area, cross-sectional area is basically these disks that you get. That's why you call it the disk method. And to find the area of the disk is pi r squared. That's the reason why we say, that's the reason why you have f of x all squared, where f of x is represented as the radius pi r squared. We'll do some example on this. Now, if you have two curves, you have a top curve and a bottom curve. So I'll just draw some quick diagrams and then we will solve problems. What if we have area between curves? So I'm taking the most basics. So just say if we have a straight line, right? Just say if you have a line, straight line, and we basically have a parabola and we are rotating about the x-axis as well, right? So if I rotate this about the x-axis, you form an image, right? Like this. And you're basically rotating about the x-axis, right? So you will get something like this. So let's try to put the rotation here. So in this case, you get a washer. The cross section will be a washer. What's a washer is two concentric circles. They share the same center. You have a smaller radius and a bigger radius. To find the area of this cross section, which is this part over here, that's what we will be doing in problem solving. We need to take the bigger radius, the outer radius minus the inner radius. So radius outer. Remember, we're finding area, so it's pi r squared, pi r outer radius squared minus pi r inner radius squared. So that's what we have here. So f of x is the outer radius, which is the top part, right? And this is the inner radius, which is the bottom part. So they use it in terms of graphs, and you're integrating the volume over the points of intersection from 0 to 1. Now, what happens when you are rotating about the y-axis? If you're rotating about the y-axis, example, a curve like this, and the volume of you're rotating this about the y-axis, you will get something like this, right? But now your function will be in terms of a of y, right? Which is pi r squared. This is a disk method, pi r squared. So where's your radius? Your radius is somewhere inside here, right? Okay, that's your radius. Radius is in terms of y. What happens when you have two functions? If we have two functions, example, you can take the same thing above, right? A straight line and a parabola, right? And rotate it about the y-axis. Then the image formed will be that, right? And there's your cross section here. I'm drawing it in yellow, inner and outer. So you're going to find the area in terms of y, which is pi outer radius squared minus pi inner radius squared, right? And this is outer one will be the bigger one, bigger radius minus the inner radius to get the cross-section area. We'll do examples on every type of problems here. Next, when we're rotating about a line other than the x-axis, right? We will use these two formulas, but I will come to that later on. Let's do the first example. Now, introduction, you remember the volume of a cone, okay? Volume of a cone is equal to 1/3 pi r squared times height. Now, let's try to prove the volume of a cone using integrals. Now, how do we go and do that? Now, remember what a cone is. I'm putting a sideway cone, right? So I'm making a cone like this. Let's just take a line, for example. I'll take a line. Which is and like this, right? And I'm starting from 0, right? This is the, remember, usually the distance from there to there gives us the height of the cone. So I'm calling this h, right? I'm rotating this line. I took a line here, right? From starting value to ending value. I'll tell you where the ending value is because we have to end it somewhere, right? So there's the ending value here. I'm gonna break up this line here because, yeah. So the distance from on the x-axis is 0 to h, right? And the distance from here to there, the distance from here to there is r, because I'm rotating this about the x-axis, okay? Right, I'm going to rotate this about the x-axis. So now if you rotate this about the x-axis, the image formed will be basically, when you're doing a rotation, you will basically get a cone. So let me draw this cone here for you. Hmm? Right, and because you're rotating this line about the x-axis, right? And you can see every cross section that you cut out will be circles. Now I'm taking this cross section here. We said the distance from there to there is h. Let's call it not h now. Let's call the distance from there to there x. X is better because remember that's the height of the cone. So let's call this x. The distance from there to there. Okay, what if it is h? What's the equation? Yeah, it's fine. H is fine. So the coordinate point over here is h and r. Any questions so far? That's the height of the cone. That's a radius, okay? I'm just giving you some points. That's h and r. So what's the equation of this function f of x? This line here. The equation of this function f of x is y equals mx plus b, right? B is 0, and the slope is change in y over change in x. So r over x, all right? R over h. Change in y over change in x, r over h, x. So great, I have the function, which is r over hx. What is the area of the cross-section? Now, the cross-sectional area I have to draw, okay? So I have a center, which is the center line is the x-axis, all right? There's my cross-sectional area here. I'm going top. So the distance from here to there. Now, what is the distance from here to there? If I take a general point x, any point from here to there, from 0 to that point, x, right? 0 to x, if I take any cross-sectional area, so the distance from 0 to x will be x, right? And what is the height? The height is, what is the height? The height is
So it's the
y.
radius of the circle, or
Yeah,
y in
the
this
height
case,
is
yeah.
y, and y is f of x, right? So
Okay.
the height is y. So now let's write down the cross section of this. So what's the radius area of this cross section? the entire area. This is called the disk method, right? Area is equal to pi r squared. But what is r equals to? R is equal to y, which is basically equals to, what is y? Y is a function in x, right? Which is r over hx. Are we good? So what's the radius we are squaring? We're taking pi into r over h and squaring. Now, if you simplify this, this is just x squared, and all of this is pi r squared over h squared, pi r squared over h squared, x squared. And you are integrating from 0 to h, okay? Where x is between 0 to h. That's your boundary that you are integrating from. Remember, this function is only drawn from 0 to h, okay? So let me take 0 to h out. The function is drawn from 0 to h. Therefore, what is a volume? Volume is integral a to b of area in terms of x dx, because this is the rotation about the x-axis of dx. So what is this? Integral a to b, not a to b now because we got the x boundaries, which is 0 to h. Okay, what's area of x? Area of the cross section. This is a cross sectional area. The cross sectional area is basically equal to pi r squared h squared x squared dx. Now remember, your integral is in terms of dx, so only x is your constant, x is your variable, everything else is a constant. So you can say pi r squared over h squared. It's just a constant, and I'm integrating x squared, so that'll become x cubed over 3, right? And this is from 0 to 8. Now, if I substitute h inside, I will get pi r squared over h squared times h cubed over 3 minus 0, right? Because x value is 0. And guess what? H squared and h squared cancels out. What do you have? You have what? 1/3. You can see this here cancels out. You can see the h squared cancels out with h squared. So you're just left with 1h on top. And you are left with 1/3 pi r squared times height. And that's the volume of the cone. Okay, so you use integrals to prove that the volume of the cone is actually 1 over 3 pi r squared times height. Are we good? This is called the disk method. Now, let's take some examples and solve using disk method. To solve the first problem.
Wait, Mr. Before you continue, can I finish this? I'm not done yet.
Yeah, of course.
Yep.
So first find the area of the cross section. After you find the area of the cross section,
Yeah.
right?
We
Just
integrate
integrate
that.
the area
Yeah.
over the x boundaries.
But Mr. I have a question. How did f of x, because in the original equation it was f of x all squared.
Yeah, that
How
is
did we
correct.
go from
F
that
of
to
x, f of, you
ax?
see, yeah. You see, this is pi times f of x all squared is the same thing as saying pi r squared. That's why I just write area.
Okay,
Pi r squared
I
is just
see.
the area, because this
Yeah,
is
got
like
you.
f of x is like your r, right?
Mm.
So that's why I just say from a to b, just use this area of the
Just
cross
put the
section.
pi back inside and okay, I see.
Yeah, I don't use
Okay.
these formulas. I just use area of the cross section.
Mm.
I just
Yeah.
integrate the cross section and I'm done.
Okay.
Because these formulas are kind of confusing. But if you draw the diagram and try to
Yeah, then it makes
understand
a
where
lot
the
of
cross
sense. Yeah.
section is and what's your rotation is very easy. If
Mm.
you're going to try to use what you call formulas, you will get confused. It's better to use diagrams
Yeah.
and draw the cross section. Disc is either a disc or washer. When do you get a washer? When you have two curves. And when do you get a disc? When you have a single curve.
Okay.
Are we good?
Got you. Yeah.
Right.
Mr. Okay, this is a bit of a stretch, but what if there's like an actual curve, like a quadratic curve, or
Yeah, it's
maybe
fine.
a
You
hyperbola?
can,
Will it still
yeah,
work?
yeah, I have
Okay.
questions. I have questions
Okay.
based on all that.
Okay.
Right. Find the volume of the solid generated by revolving a region bounded by y equals root x, y equals 0, and x is equal to 4 about the x-axis. So you need to draw all these curves and say, what are we talking about? Where is the region bounded? Where's the boundary region? And we're revolving around the x-axis. So our integral will be in terms of x. Okay. Now, let me draw this. How do we draw y equals square root of x? Remember when we did functions, I showed you how to do that. Square root of x is basically a function like this, right? Y equals square root of x is a root function. So it starts from 0. Now, y equals 0. What is y equals 0? Because the y-axis at 0, so this is the line, and x is equal to 4. So you're stopping at 4, right? Because they're telling you y equals 0 is here. There's a line y equals 0, and x equals 4 is right here. Now, why did they give us these three curves? Because you have a stopping point. You can't go beyond that because you're trying to find the volumes of solids of revolution, right? Now, you're taking this curve over here, right? And you're rotating it about the x-axis. So you can put the rotation here, right? Your x-axis. So let's rotate this about the x-axis. So find the image. That's a problem. Let's try to. Okay. Now, what is this point over here? This point over here is basically 4. So I know my integration boundaries from 0 to 4, right? I'm going to be integrating from 0 to 4. And you are rotating about the x-axis. So there's your discs forming, multiple discs forming. You can see this here looks like a bowl. Can you see? Now I'm going to take this cross section. I'll define the area of this cross section here. So I'm pulling out this cross section. Watch. See the distance from there to there is y value, right? So I'm going to pull out that cross section. Let me make it like this. It's still a circle, right? That's the radius, which is the y value. And you know what is y equals to? Square root of x. So radius is equal to y value. And what is the y value? Y value is the square root of x. So what am I going to find? Area of this cross section, which is a disk. So area is equal to pi r squared. Pi, what's r? R is square root of x, okay? Square that, and I just have pi times x, because square root of x all squared is just pi times x. And what are you doing? To find the volume, integrate from 0 to 4 of pi x dx. This is an easy peasy integral, isn't it? Because it's like polynomial, power rule. Take the pi out, okay? Take the pi out, that is x squared over 2. Integrating x is x squared over 2. Add 1 to the power divided by the same power, 0 to 4. If you substitute 0, you're going to get 0. So just substitute the upper boundary. Pi, 4 squared is 16. 16 over 2 is 8. So 8 pi units cubed. Should have
So
written
this is
units.
specifically for the area of what? Of the curve
No, no,
up,
no, 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 no. It's not the area, it's a volume of this entire
sorry,
solid.
volume. Yeah, we were
It's
just
like a
okay.
solid, it's like a bowl.
Yeah. So this is the volume from point 0 to point 4, right?
Yeah, yeah, yeah.
Okay, and we
You don't
got
get
that
it.
using any cross section of any cross section circle of this equation, right?
Yeah, yeah. You just take a cross section in the center because remember, if you take a cross section, you're gonna get like a disc.
Yeah,
Think about a bowl.
the
If
disk
you
method.
if you slice a
Yeah, I
bowl,
got you.
you're gonna get,
Yeah,
yeah,
same with the
you will
cone and
get,
same with
yeah,
yeah.
same with the
Okay.
most of the curves, you're gonna get a disc.
Yeah.
Are we good, guys? So far, remember,
Yeah, so far so good.
look at the method that I'm using. It's very important. I'm not using formulas at all. I'm just integrating the area of the cross section. That's it. It's the same thing as using the formula. If you are going to use the formula, sometimes you will get confused. But in this disk method, you won't get confused. It's easy because the volume formula is pi integral a to b of f of x all squared dx. And that's pi 0 to 4. What's f of x all squared? F of x is root x, and you squaring root x. It's the same thing, right? That's why I don't like to do it like this. I rather take the cross section out separately, find the area of the cross section, and then integrate to find the volume.
Mr. One thing in the last in the previous question, you mentioned that y equals f of x. In this question, can we assume, rather, can we assume that for all questions, where okay,
Yeah.
this y is equal to f of x is equal to root x? Can we assume it that way? And then if we want, we use the original first equation.
Most f of x is the y value. So it is an assumption that you make. F of x
Okay,
is the
it's
y
a
value.
general assumption we
It's a
can put on
function, yeah.
everything, right?
It's a function in, it's
Okay,
a function in x.
yeah,
It's
okay,
basically y.
yeah.
So you can apply to all disks in that case. Second example, all right? Now I'm doing a washer method where I'm taking two curves. Now, guys, these are just general functions that I chose, polynomial function. You can get any function. You can get trigonometric functions. You can get sine and cos. You can get you can get ln function, any function, right? Right, so the region R bounded by the curves y equals x. Watch here. What is this? Y equals x and y equals x. We revolve around the x-axis. We are revolving around the x-axis. Compute the volume of the solid generated by this rotation. Now, it's very important. Where is this? Y equals x and y equals x squared. First, I need to find the points of intersection because these are two functions. This is like y1, y2. So I'm going to say x is equal to x squared. X minus x squared is equal to 0. Take out x as a common factor. I'm left with 1 minus x is equal to 0. So this implies I have x is equal to 0 or x is equal to 1. These are the points of intersection points, right? This is the first thing that you do. Try to find the intersection points. And we're rotating about the x-axis, so we know where we are integrating from. So we know we have boundaries, intersection points. Okay. Let's take all this down. Right, so we have intersection points. Now, problem is, how do you know which graph is on top, which graph is at the bottom between 0 and 1? You can only sketch the graph between 0 and 1. So if I'm sketching the graph between 0 and 1, the easiest graph to sketch is a straight line. Right. Now, remember, the straight line graph is a 45-degree line. Right. And we are sketching this graph, which is between 0 and 1. So I drew this line here between 0 and 1. So let me take this piece out. Shouldn't be there. Right, so this is y equals x. Now let's substitute, let's try to find y equals x squared. If the value of x is 0, it is 0. If the value of x is half, then it's quarter. So that point is somewhere around here. Quarter is somewhere around here. If it's half, then it's quarter. So you can see this parabola has to be sitting down. The quadratic function has to be below the straight line. Right, now I'm rotating this about the x-axis. Right, that's my rotation. Now I'm going to take this and draw an image of this, right? Mirror image. So remember this point, by the way, this point is 1 and 1, right? Now, yeah, so this inside piece will be this red piece over here. It will get wider. right? And I'm rotating this about the, what happened here now? One small now. Right. Now I'm rotating this. So where's your cross section? Cross section is this piece of here. Let's go somewhere in the center. So I have an outer radius. That might, okay. So I have, let's take a cross section between 0 and 1, any point between 0 and 1. So I have something there, and I have another one here, right? So that's the, you see, you have a disk between those two curves, and you have another disk on the outer curve. So this is what you have. The cross section, right? You have one circle, and you have another. Let me draw it in different colors. Right, so you have this green circle, and you have the green one will be on the inside. And the outer one is, let's take a different color here. Right. Let me do this for the same thing. Trying to find the volume of the washer. Now, sorry, the volume of this solid when you rotate it about the x-axis. Now, see, you have a common center point. So you have an inner radius, right? So I will call that Ri, inner radius, and you have an outer radius, which is the, from the same center, going to the top of the curve, right? So this is R out. Now, if you try to find the area of this washer over here, area of the shaded portion, how are you going to find the area of the shaded portion? Just normal. So this is the washer method because you have two curves. So to find, this was the cross section, right? And this is the graph. And we're integrating from 0 to 1. So those are the three important things that you need to know. Let me take this x-axis rotation. You know how you're rotating, so I'm just drawing it. So now what's the cross section area in terms of x? Just write area is equal to pi, the outer radius, which is vertical, squared, minus pi, inner radius squared. Example, if I ask you what's the area of this, if this is 5 and that's 10, or just say this is 5 and that's 12. I'm giving you values now, right? Then it'll be easy. You say 12 squared minus 5 squared. Anyways, now what is the outer radius? R out. R out. The outer radius is the bigger radius, okay? There's the outer, it means the top part, the bigger one. The outer radius is from the x-axis to the top of the curve. So it's a straight line. Outer radius is y top, the top function, which is equals to, what's the top function? The straight line, which is
Mr. Y
equals
equals
to,
X.
yes, x. So you got pi times x all squared minus pi. What's the inner radius? R in.
X squared?
X squared.
Good. That's the bottom function, which is x squared. Squared, squared. Because you're finding the area of the cross section. Now you can say area of the cross section is pi x squared. You can take out pi as a common factor. So you got x squared minus x to the power 4. And now its volume is easy. Volume is equal to integral 0 to 1.
So we
Put a
can
pi
take out pi
outside.
x squared. We
Uh-huh.
can take out pi x squared, no?
No, no, no,
Pi
you
x
can't take
squared
out
is a
the
factor. 1
you
minus
integrate
x
it.
squared.
You can't take out the x squared as a common
Oh, yeah,
factor
you can't take out
because
x.
you're integrating
yes, yes,
x.
yes, yes, yes. My bad. Yep. Squared
We're
minus
not
x.
we're not doing HCF. We're just taking out the constant.
Yep.
So this is easy. You take pi and you're integrating that. That's x cubed over 3 minus x to the power 5 over 5. from 0 to 1, okay? So you got pi there, that's 1/3 minus 1/5. And if you substitute 0, you get 0, right? That's over 15, so you should get 2 pi over 15. Just check that up. 5 times 1 is 5. 5 minus 3 is 2. 3 times 5 is 15. Otherwise, you can do your basic algebra. Multiply by 5, multiply by 5, multiply by 3, multiply by 3. 5 times 3 is 15. There's a 15 here at the bottom. And 5 minus 3 is 2. 2 over 15 pi. Units cubed. Right. So great, guys. So we did rotation about the x-axis. You understood everything and you understand what you need to do. What you need to do, intersection points first, graph, cross-section, and ta-da, you're done. Integrate the
One question.
cross-section.
I
Yeah.
don't understand. Why did you say that we're gonna the air O is bigger than air I? Yeah, you say that. I remember.
No.
But
I said the top function and the bottom function. Yeah.
oh yeah, right. Yeah, yeah.
But
Yeah,
but
fine. Yeah.
the top function is bigger. The radius, the outer radius is bigger than the inner radius, because if you have to actually find the area of that cross section, if you have to find the area of that washer, you will basically take the outer radius. You'll take pi r squared outer minus pi r squared inner.
All right. Okay.
You understand? You have to
Yeah.
take the big radius squared minus the small radius squared, obviously multiplied by pi and multiplied by pi.
But in that case, the x square is has the biggest radius, no? Not the x.
No. We're not talking about. We remember. This here means not big. This here means the top function. It means this is the bigger radius. See, from the center to the top, there's the bigger radius. So the bigger radius is r outer. So it is x, because it's between 0 and 1. You
Oh.
see, it's between 0 and 1. That's why.
Yes.
That's the
Yeah.
reason
Okay.
why.
Okay. Yeah. Yeah. Okay. Yeah.
We
My
try to
bad. My bad.
calculate a
Yeah.
y value. Remember
So
when we
what's the answer?
put
2 pi over 15 units
yeah.
cubed, right?
Yeah.
Okay,
We
okay.
had that.
Yeah, there
Right,
it is. Okay.
excellent. Right, great.
Okay.
Next question, guys. We're going to rotate about the y-axis now. You did the rotation about the x-axis. I gave you a disk and I gave you a washer. We're going to do the same with the rotation about the y-axis. Rotating about the vertical line, y-axis. Find the volume of the solid generated by revolving the region bounded by y equals x squared, y equals 0, and x is equal to 2 about the y-axis. This is an easy function. Y equals x squared is basically a parabola. There's no points of intersection here. You only get points of intersection when you have 2 or more curves. So you just have a single curve here. I'm just going to draw this parabola y equals x squared. And we're rotating y equals x squared is a function like this. It's a parabola, right? But now they said, and x is equal to 2. So the stopping value is 2, right? So we're stopping at 2. Stopping this function at 2. And there's nothing here, because I drew y equals x squared, okay? I have y equals x squared, which is here. Y is equal to 0 is a horizontal line. Y equals x squared, and x is equal to 2. X is equal to 2. Let me just end it off here, right? And call that point 2. Now it's very important. If this is 2, right? What's the y value? 4.
It's 4.
Always put the coordinate down, yeah. And the rotation is about we're rotating about the y-axis, correct?
Y-axis. Y-axis.
Yeah. Right, so we are rotating about the y-axis. I don't even use any formulas. I like to draw it and then, right, so that's y-axis. You see why I don't like formulas. Now, see, I'm going to draw the image formed, right? And I'm going to draw my 3D figure. Okay. Now, you can see because you're rotating about the y-axis, your discs are inside here. Let me draw a flat disk. Like, let me actually draw the disk. See, your disk is here. Okay. That's where your disk is. Are we good? Now I'm going to take this cross section. I'm going to take this disk. I'm finding the area of that disk. So let me make it into a circle. Can you see? The top view will be a circle, right? When you're cutting this piece off your cross section, that's what a cross section is. But now the cross section will be horizontal. Okay. So this is the radius. So what is the area of the cross section now? Remember, you're rotating about the y-axis. So your radius is equal to, if you go in this direction, what direction is this?
So is it x? R equals x?
Yes,
Okay.
r is equal to x.
But we
And
don't know
what
the
is
x
x equals
distance,
to?
right? Oh, x equals 2.
We do know. Y is
X
equal to x
equals,
squared.
or
Wait.
so x
Y is
equals
equal
Root
to
of
x
y,
squared.
square
root
root
of
of
y,
y.
root of
Yes,
y.
x
Okay,
equals
okay,
root
okay.
y. Good. It has to be, the function has to be in y now, root y. So
Yep.
x is now equals to root y. So now you're going to have area in terms of y, which is pi r squared. What's the area of the circle? Pi r squared.
Oh
So which
yeah.
is pi,
Okay.
because you are doing a rotation, it's always going to be pi r squared, area of a
Yeah.
circle. Yeah. So when we're doing washes, it's like taking the area of the bigger circle minus the area of the smaller circle. That's what I should have said.
Hmm.
That's the area of the smaller circle. That's the area of the bigger circle. That's what we are doing in this area of the circle. That's what a
So this
disk
one
is.
is much easier though compared to
Of
washer
course.
method. It's not easier, but it's like
No, no,
less
no.
time
This,
consuming.
look, disk method you only use for single graphs.
Yeah.
But if you have two or more graphs, you got to use washer method.
Hmm.
Anyways, pi r squared. So what's r?
It's pi
Root
y.
y.
Y pi.
Pi y. Let's keep it as pi y.
Yeah.
And what's the value of y? From where to where? From 0. The y value is going from 0 to
0
4.
to 2. 0
Uh,
to 4. Yes, yes.
2 is the x
X is 0
value,
to 2. Yeah.
integrating. So y is an element from 0 to 4. You're integrating from 0 to 4. So
That's a
volume,
bound?
yes, that's your boundary.
Okay.
So y boundaries, you're integrating over the y boundaries. Remember, that point is 4. That's why I put the coordinate 2 and 4. You're integrating
Hmm.
over the y boundary now.
Yeah.
When you finding the volume about the x-axis, then you're integrating over the x, isn't? You're
Yep.
rotating about the y-axis. You have to integrate over the y. So volume is from 0 to 4 of pi y, area in terms of y, pi y dy. Take the pi out and integrate y. So that's y squared over 2, 0 to 4. Are we good? If
Yep.
you put 4 inside, you get 16 divided by 2, 8
So I
pi.
got 8 pi units cubed.
Mhm,
Yep.
correct. That's your volume. Easy.
Okay. Yeah. Wow.
Right. Now let's look at the same concept, but using two graphs now. You might get confused. Please don't get confused, right? Because I don't like formulas. You will see
Wait, sorry, mister, can
what
you repeat that? I didn't hear that, sorry.
I'm saying. You might get confused, but no
Before
need to,
that.
because we need to sketch a graph to solve, right?
Okay. What's
Let's look at
different about
question.
this one?
Let's look at the graphs. The graphs might be a bit confusing. So we
Oh,
got
okay.
x equals 2 minus y squared and x equals y to the power 4. Okay. Now let's discuss x equals 2 minus y squared, right? So 2 minus y squared. Quickly, let's sketch the graph. So the graph, this graph is sideways, okay? X minus 2y squared is sideways and shifted 2 units. So where's x minus? Let's look at x is equal to y squared. X equals y squared is like this, right? X equals negative y squared opens up to the side, okay? And if I say plus 2, you're moving it 2 units. Is it up or down? Up. Yeah, plus 2. So in other words, if the if the y value is 0, then the x value is 2. If y is 0, if you're finding x-intercepts, you need to make y 0. So the x value is 2. Yeah. So it's going to start here. So watch this graph here. X is equal to 2 minus y squared. You can use the intercept method as well to sketch the graph. I'm just shifting this graph. That's 2 minus, this is x equals negative y squared, right? So I'm going to move this graph. I wanted an entire piece of this graph here, right? Let me trace it out.
Mister, it's also 2 units up, right? So we're gonna move that later.
No, this one here.
Yeah.
X is equal to minus y squared. If the y value is 0,
Then
then
x
the
equals 2.
x intercept is 2. I'm using the intercept method. So x intercept is 2. I'm going to move this graph
You're moving it,
there.
right? Yeah, okay.
Yeah, I'm
Yeah.
moving it there, right? So this part is out. So I'm just showing you how to sketch that graph. Now, that piece is done. This graph is done, right? Now let's look at x equals y to the power 4. X equals y to the power 4. What about x equals y squared? X equals y squared is like this. And then y to the power 4 will be a little bit more going faster, right? It's a little bit more on the inside. So that graph is a little bit more on the inside like this. Oh, look at what we are rotating. What are we rotating? We are rotating this region bounded here. Can you see? So we need the points of intersection here, guys. That's a bounded region. That's a region that we are rotating, okay? Let me draw this in broken lines now. Undo. Right, so I'm gonna put this in broken lines. Because that's not part of the graph. Remember, I went and sketched the graph first. I was supposed to go and, find the points of intersection, all right? Because we needed to know. So let's move the graph to the side. This was just explaining to you how to draw these graphs. Now let's move these graphs to the side. Okay, so we need to focus on points of intersection, all right? Intersection points. What's the intersection points here? We can say y to the power 4 equals, remember, you can equate both the x values. So you can say y to the power 4 is equal to 2 minus y squared. Bring the y squared over, you got y to the power 4 plus y squared minus 2 is equal to 0. What type of function is this? It's a quadratic, okay? Why? Because what's a quadratic function? X squared plus x, ax squared plus bx plus c is equal to 0. That's a form, all right? Now you can see this one and this one is 2 and 1. It's always divided by 2. So whenever you see that the powers are divided by 2, for the smaller power, it's a quadratic function. It's just another form of a quadratic function. So now I can write this as y squared and y squared, right? And 2 and 1 will work, 2 and 1. How will it work? Plus 2 and minus 1 will work, okay? So y squared times y squared is y to the power 4. Y squared times 2 is 2y squared minus 1y squared is plus 1y squared. Minus 1 times 2 is minus 2. So all three terms works. So over here, solving this will give us y equals plus minus 1. And this one here, y squared is equal to negative 2. Reject non-real solutions, okay? So we have we have y-intercepts, which is at negative 1 and 1 points of intersection, okay? So what's your y boundaries? Y is an element from -1 to 1. We know where to integrate from. Now comes the cross section. Remember, we're rotating about the y-axis. Okay. Are we good? Isn't these graphs are symmetrical? Yeah, these graphs are symmetrical. Let me just stretch this a little bit more. Yeah, that's good enough. All right, so that's fine. 1 here, -1 there. And the rotation is about the y-axis. You good? Now, because you're rotating this about the y-axis, let's look at this point over here. We need like a symmetry here happening, okay? So I'm going to draw, where was this point over here? This point was at 2. So this point will be at -2, okay? Okay. And that's the graph of that. And what about this graph? It's like enclosed, right? Let me draw this. Right. Very good, guys. Now let's look at the inner radius and the outer radius. Watch here, I'm going to take the cross section here. Obviously, the cross sections will be horizontal. Look at this piece here. See that piece there, from there to there, okay? Take the cross section there. How about going at the bottom? Let's go at the bottom. Need more space here on this. Right. That's the inner curve. And where's the outer curve? Right. So it's like you're looking at the top, looking at it from the top. Okay. Now, if you're looking at it from the top, I'm going to look at the cross sections here. Inner circle, outer circle. Right. So what I'm looking at is a cross section. Top view. So there's your inner, R in, and this whole thing is R out. Okay, so now what's your R out? Is that purple graph, right? R out is a purple graph. Are we good? Which is your X value. Outer radius is your X value. And X value was what? The outer one. What's the X value? 2 minus y squared, okay? There's the X value here, 2 minus y squared. Are we good? That's a purple graph. That's the outer one. Are we good,
Wait,
guys?
Mr. I have a question. If they're symmetrical, how do we know which one's on top? Oh, okay, no, it's there. It's right there.
No.
Yeah, okay.
Is outer one and the inner one.
Yeah.
The inner
So
one is the square. Remember, the inner one is the y to
is
the power
the
4 function.
y to power 4. Okay.
Yeah.
And
So
we
this
get
one
that
is out.
from seeing the
The
cross
cross
section in
section.
the middle of
Yes.
the okay.
Yes.
Okay.
Correct. And make sure when you're doing a cross section, you find a gap in between the graphs. Okay. See, like when I found a gap, you can't do a cross section at 0 now. Come on, it's difficult. Then the inner radius is also X because it's horizontally is X. And the inner radius is that which graph? the green and the black graph that
It's
I
y
originally
to the
drew,
power
which is,
4.
yeah. So now what is the, it's a bigger circle minus the smaller circle, right? What's the area of the cross section? Area of the cross section is the bigger circle, big circle. So out minus small circle, which is inside, right? Then pi, what's the outer one?
So the outer one's 2 minus y squared,
Yeah,
all
2
squared.
minus y squared. 2 minus y squared squared.
All,
Yeah.
yeah, y squared, all squared.
Can I put this in brackets? Let me put it in
Yeah, yeah.
brackets so we can just simplify the function. Take the pi out. What's R1? Y to
Y
the
to the
power
power
4
4. That squared.
squared. And that squared, yeah.
Mhm.
Right, great. So now we have pi. That is 4 minus 4y squared, middle term, plus y to the power 4. Yeah, minus y to the power 8. And we just integrate this. There's no like terms here, right? So volume is equal to integral negative 1 to 1 pi of all of this area of the cross section. dy, right? And now it's easy. Take the pi out.
Wait, mister, I need time writing this. This is a lot of stuff. One sec.
Did you're not gonna send it to us now? We can take the notes after.
Okay, listen. You can just integrate this. I don't need to, you don't need to. Remember, this function is even or odd. Everything is
It's an
powers
even
here.
function. So I
Even
can just
function,
integrate from 0 to 1.
even function, good.
And times 2.
And take the 2 out, yes. It's an even function. So the volume is equal to 2 pi integral 0 to 1 of 4 minus 4y squared plus y to the power 4 minus y to the power 8 dy. Good. It's an even function because f of negative x is equal to f of x, or in this case y. F of negative y is equal to f of y, because you can see all of them are just powers 2. It's like even powers. Anyways, this is 2 pi minus 4y minus 4y cubed over 3. It's easier to substitute 0 and 1. It's so much more easier. Minus y to the power 5 over 5 minus
you get
y to the
minus?
power 9 over 9, 0 to 1.
Mister, how
What is
is
that?
minus y to the power 5 over 5? It's plus, no?
Adding plus, yes.
Plus, okay.
Yeah,
So for where
great.
did you take 2 pi? Sorry, 2 pi for it?
No.
Negative.
The pi is there. If a function is even, remember, if a function is even, volume integral negative a to a f of x dx. If this is an even function, then you can get 2 integral 0 to a of f of x dx. Only if the function is even.
But if it's odd?
If it's odd, then it will be 0. The answer will be 0.
All right, okay.
Okay.
Oftenly
So
it will be even, yeah? Because if it
yeah,
becomes
most of
0, no
it,
solution.
if you see a symmetry, then it will be an even function.
Oh, yeah. Okay. If it's symmetry, yeah. Because in
Yeah.
our station, it's symmetry. Yeah, okay.
Yeah, in our case, it's like it was symmetrical. Yeah, so great. And also you can see that this whole thing is an even function, like all even powers. Otherwise, you can just go and integrate this from -1 to 1, no issues, right? And then this is just 4 minus 4 over 3, 4 minus 4 thirds plus 1/5 minus 1/9. Right, you can just work this whole thing out on the calculator. You should get an answer. Let's see. 4 over 3 plus 1 over 5 minus 1 over 9 press equals 124 over 45 multiplied by 2, 248 over 45 pi, 248 over 45 pi units cubed. Okay. Yes, that's what we have. And if you go to your notes, remember what I put here? Washer method, region bounded by x equals f of y and g of y. So that's a left and that's a right. So you're going to take the right function minus the left function, square, square, put the pi outside. So it's correct. So it's like using bigger circle minus smaller circle with a pi, right? The same thing. So I don't like to use the formula, just use this. All right, guys. Very nice. Nice question.
This was a good one, mister. It took it took the full page rather.
Right, excellent. Let's look
Crazy
at another
question.
one. Now we look at something better. Now rotating about general lines, not x and y axis. We are rotating about a line, not about x and y axis now. A little bit more challenging. So we're going to rotate about the line y equals 6. All right? Not about x and y axis. About the line y equals 6. Remember, rotation about the x-axis also means rotation about the line y equals 0, right? Y equals 0 and x-axis. What does y equals 0 mean? About x-axis. Make sense? Y equals 6 is like saying you're rotating about the horizontal line. X-axis is still horizontal line. So your integral will be in terms of dx. Okay. Now let's draw this graph and see what are we rotating. Try to find what we are doing. So we have to draw the graph. No points of intersection here because this is straightforward. Let's look at all the factors involved here. Generated by revolving the region bounded by. So where's the region bounded by y equals x squared and y equals 4? Y equals x squared and y equals 4. Whoa. I need a bigger here. Explain it to you properly so you don't ever make mistakes. Right. Now I have y equals x squared, okay? You're going to understand this like a king. It's amazing, right? This is y equals x squared and y equals 4. I'm going to draw both the graphs. And y equals 4 is just a horizontal line, okay? At cutting at 4. Let's just say this is y equals 4. So obviously now you have this point here is basically 4, right? And you are rotating now about this line. Look at the line that you are rotating about. That line, right? This is y equals 6. So what you're going to do, 1 second, let me just, this is not looking symmetrical. A little bit more towards left. This should be fine. A little bit more. Okay. This is 6. Now you are rotating about this line. You need to look at the rotation. Reflect the image across. Okay. So I'm going to reflect this image across here. Where's the reflected image? Okay. So if this was 6, this is 8. Okay. And where's the rotation? There's a rotation here. So where's your cross section? Your cross section will be any point in between this, the vertical cross section. Let's use cross section, try a different color. Then I'm taking a cross section here vertically, all right? I'm taking a cross section vertically because I kind of have like two graphs, y equals x squared and y equals 4. That's one cross section. I'm taking another cross section here. Actually, don't take a cross section at 0, right? That's what I said before. Take a cross section somewhere around here. Take a cross section here. Okay. There's one circle and there's another one. That's an inner circle. Where's the outer circle? Outer circle is here.
Teacher,
Good.
if it will be 1 second, if it will be x in the x, it will be like x equal to y square and x equal to 4. It will be like you put in the right side the circles, or
No,
how we
sorry, I
gonna
didn't
put
get
it?
you. Yeah.
No, be,
I'm coming to that. See, there's my inner circle, right?
okay.
I'm doing the washer, right? It's a washer method, and there's my outer circle. Now watch. Where's your symmetry here? Now there's your symmetry here, right? Now look at the distance from the center to there. What's your inner circle radius? Your inner circle
Like
radius
2?
is not yeah, it's just 2. That's it, good. Your inner circle radius is 2, good. So R in is just basically 6 minus 4, which is basically equals to 2. Now, let's focus on this distance over here now, because that's your outer circle radius, okay? The entire distance from here to there is 6. But now see where the graph is touching, there. What is the distance? What's the height over here? Y, correct? So your outer circle, see what's the distance from there to there? So now from there to there is, look at this point here. The entire distance from the line 6 to the horizontal x-axis is 6. And look at this point over here. This point over here is y. So my radius is until y. So I'm going to go from 6 until this point over here. So I need to subtract this distance y. So 6 minus y. But what is y? Y is equal to x squared. So 6 minus x squared. Are we good, guys? Did you get that?
Yeah, this one is great to study.
You understand?
Yes.
So I'm going to try to lift the see, there's my thing. I'm just lifting it just above the x-axis. It can't be 6 because it's sitting above. The distance from here to there is y, and this entire distance from there to there is 6. So I want the outer radius. The outer radius will be 6 minus y squared. Okay. The distance from the x-axis to that point is y. So 6 minus y squared. That's great. Now, to find the area of the cross section, what's the outer radius? 6 minus x squared. So pi, bigger circle minus smaller circle for the inner circle. Take the pi out. What's the outer circle? 6 minus x squared. Squared. Subtract. What's the inner circle? 2 squared. The inner circle radius. That's easy to expand now. That's pi. Open brackets. That's 36 minus 12x squared plus x to the power 4 minus 4. Okay. And the problem is, where are you integrating from? You're integrating from Oh, wait a minute. The y value was 4. You're integrating over the x-axis, all right? So you were supposed to solve for x because it's two equations. So points of intersection is x squared is equal to 4. This is intersection points equating both the y values. That's y1 and y2. So x is equal to plus minus 2, right? So you're integrating over this boundary here. Okay? So the boundaries of integration is from minus 2 to 2. So where x is an element from minus 2 to 2. So you're going to have pi, that's x to the power 4 minus 12x squared. 36 minus 4 is plus 32. So the volume is equal to integral from negative 2 to 2. I can take the pi out.
Mr. Isn't this is
Even
a
as well.
symmetrical thing, right? Yeah,
Yeah,
it's
you
even.
see an even function. Don't think
Yep.
about symmetrical. Just look at the function and check whether if it's even or odd.
Yeah. No, it slipped out. My mistake, it slipped
No,
out.
it's fine, it's fine.
It's 12
12x squared plus 32 dx. So
dx.
this is another even function, so we can make it 2 pi 0 to 2 x to the power 4 minus 12x squared plus 32 dx. And I integrate that and solve. 2 pi x to the power 5 over 5 minus 12 divided by 3 is 4 x cubed. If you differentiate this, you get minus 12x squared, it's correct, plus 32x 0 to 2. Just substitute 2 and you will get the answer. 2 to the power 5 is 32 over 5. 4 times 2 cubed. 4 times 2 cubed is
It's 32. 8 times 4 is
32.
32. Plus
And then you
64.
got plus 64. 64 minus 32 is 32. So you can just work all this out. Guys, come on. You're allowed to use a calculator. I'm just going to use a calculator now. Almost brain fried here. 2 shift pi, open brackets, 32 over 5 plus 32. Minus 32 plus 64 is plus 32. 384 pi over 5. 384 over 5 pi units cubed. Right. And last one. Now, let's look at the rules for this now. What happens when you rotate about a line? You can go and learn the rules, but I just like to draw it and check. You can learn the rules. Rotating about a line, we were rotating about y equals L. So see what he says, top curve minus L all squared, or you can say L minus top curve squared, and you can say L minus bottom curve squared. Because you are squaring, it doesn't matter whether it's L minus or, okay. You can just say top curve minus L squared, bottom curve minus L squared. So in your case, if you use the formula like this, you didn't even need to draw the graph, nothing, but you still got to find the points of intersection. What if you use the formula in this case? If you went and used the formula, you need to figure out which is the top curve and the bottom curve, right? And I'm just going to put it onto the calculator and show you that it works. Oh, volume is equal to pi. You are integrating from minus 2 to 2. What's the top curve? The top curve will be, what was the top curve? The parabola, right? No. The top curve is this line here, 6. No, sorry. The top curve
Oh,
is
Mr.
4.
Top curve is the
4.
parabola, x squared.
No. Sorry. The top curve is 4. They said top curve.
How?
Top curve is 4. The bottom curve, top and bottom. Top
Oh,
is a
okay, that
horizontal
top.
line. The
Yeah, yeah.
bottom, yeah,
Yes, yes, yes,
not
yes.
the rotation.
Not
You're
the
rotating
inside
about
and
the
outside.
line. Yeah,
Okay,
this is a
okay, yeah, I
rotation.
got you. Yep,
So
okay.
that's 4 minus 6 squared. Subtract. What's the bottom curve? Bottom curve would have been the parabola, right?
Yes.
Bottom curve is what?
Wait.
The parabola was
Oh,
y equals x squared minus 6 all squared dx. But this doesn't make sense
Sir,
because now
what's
you're gonna have
6? 6 is the line we're rotating about?
rotation. Yeah,
Okay,
yeah, yeah, yeah.
okay.
We're rotating about the line y equals the top
Yeah.
curve was 4, bottom curve was x squared,
Mm-hmm.
and L was 6. Let's put all
Okay.
this in the calculator and see if you get the same answer. Otherwise, don't use it. Shift pi integral minus 2 to 2 4 minus 6 also it's just 2 squared, right? Subtract alpha x squared minus 6 close bracket to the power 2 another bracket. I'm getting a negative answer, which means that they didn't
Sir, maybe
account
it's
for
from
the
0 to
area of the
2?
cross. No. They didn't
Oh, it's from
account for
A. It is
the.
from A to B. Yes. Yes, yes, yes.
See, this you're supposed to take the bigger circle minus the smaller circle, but you see now this is the inside circle. Yeah, it's a problem here. Don't use it. You see, you're getting a negative answer, so you can just flip the negative, make it positive. So now you need to say a negative pi. I think it's missing a negative here. So it's supposed to be bottom curve minus L all squared minus, supposed to be this minus that. So just put a negative pi here. So now you're getting 384 over 5 pi. You know what they did here? This is the smaller circle, and this is the bigger circle. We're supposed to do bigger minus small. That's why I don't like to use
Sir, maybe
formulas.
they,
You see?
I think they confused it.
Yeah,
It should be bigger minus smaller.
yeah. So avoid using formulas, all right? As you can see, it doesn't work. Don't you waste your time learning formulas. Just draw the function. You'll know exactly what to do. Let's look at the last question, guys. All right, question 6. I have one more question. I'm not done. Now, what we are rotating about, the line x equals -1, okay? Just draw these two graphs, x equals y squared and x equals y squared. Be careful now. Let's start with y equals x squared, normal quadratic function, right? And this is a sideways quadratic function. So let's start by finding the points of intersection. We're rotating about the line x equals 1. So it's a vertical line, all right?
yeah. It's dy.
Yeah. So it's going to be dy. Good. Because it's going to be dy, let's solve for y here. Let's solve for x here, all right? No, let's solve for y. So x is equal to root y over here. And this is x equals y squared. So that's already done here, okay? So this is x1 and this is x2. So points of intersection or intersection points is y squared equals root y. I'm going to square both sides. I'll get y to the power 4 is equal to y. Bring the y over. Y to the power 4 minus y is equal to 0. Take y as a common factor out. Got y cubed minus 1 equals 0, right? So either y is equal to 0 or y is equal to the cube root of 1, which is 1. Are we good? So I know my boundaries for y. It is between 0 and 1. Are we good? Now let's draw the graph. So y equals x squared is a quadratic function facing upwards, okay? And we know where we are sketching the graph from 0 to 1, so it's easy. It's a quadratic function, y equals x squared, so it's just 0 to 1, right? Quadratic function, 0 to 1. 0 to 1. Okay, I don't need the x boundaries. And then next one, x equals y squared. X equals y squared, so y equals root x, isn't? Y equals plus minus root x, but we can only get positive root x, okay? So remember, we are integrating this. This is square root of x. I hope you understood this. I can't draw the entire square root function because this bottom piece has nothing bounded. So that's why I left this bottom piece out. Now you are rotating this graph. You're rotating this about what? The line x equals -1. Aha. So let's just say -1 is there. Guys, you can't sit and, chill with these types of questions. You gotta do some work to solve, right? So let's continue. Now, see, I'm trying to draw the mirror image of this now because I'm rotating about this line, okay? So this is x equals -1. So if you're gonna rotate about that line, see this green portion here? You'll get something like this over here, right? A little bit more curvature. Spin this a little bit more, right? And look at this piece over here. There's a red piece over here. I'm gonna put it on this side. Put it in red. Okay, so this piece is there. Now, where's your cross section? Because you're rotating about this, there's a cross section here on the inside, horizontally. There's your inside one here. Take anything in between 0 and 1. That's a red one. Yep. Choose another color. And the outer cross section is here. Okay. Now, guys, you need to figure something out here. See, we know let's look at this smaller circle on the inside. Remember, we're still finding the washer. Now we're looking at the cross section now. Focus on the cross section. Look at this black line. Now, the distance, now look at my graph. See where my cursor is? Right there. From there to there, that distance is 1. And then you have a further horizontal distance, which is what? X. So the inner radius is 1 plus x. So what's the r inner radius? 1 plus x. Now x is touching what? X is touching the red graph. Let's go to the red graph, which is root y. What was the red graph? Yeah, x is touching the red graph, which is root y. So the inner radius is 1 plus root y. Let's look at the outer radius now. Okay. The outer radius, I'll go from the same point. Let me go to the other side. So the distance from here to there is 1. Okay. Oh, no, no, no. 1 plus, let's carry on here with the same concept. The distance from there to there is 1. Okay. So there's 1 plus x, that further x. Now is 1 plus a further from there to there. So from -1 to 0 is 1 unit. And from 0 to the green line was what? Y squared. So the outer radius is 1 plus x out. the outer function, and x outer function. Where's the outer function? Let's write it here. This is the outer function, and this is my inner function. So x outer function is 1 plus x outer function is y squared. Okay. Now it's easy to do the cross-sectional area. Any confusion? Are we good?
Yeah, Mr. All good.
I'm pretty sure no confusion, so thank you.
No confusion. Excellent. So now the area of the cross-section is pi. Bigger circle. Bigger circle is this red circle. Bigger circle. Outer circle squared minus pi. Smaller circle. Smaller circle is the inner. Right, outer minus inner. Now that's pi, take the pi out. What's the outer radius? The outer radius was 1 plus y squared squared. Minus the inner radius squared is 1 plus root y squared. So now I'm going to find area of y is equal, you know where you are integrating from, 0 to 1. So you have a pi, square this, 1 plus 2y squared plus y to the power 4, subtract, we are subtracting here, okay? Wait a minute, before did we subtract or did we add? Yeah, we did subtract the 4, that's correct. So we're subtracting 1 plus 2 root y plus root y squared, which is y. 1 plus, so the 1 and the minus 1 cancels out, so 1 is out. You have y to the power 4, I'm rewriting this, plus 2y squared, y to the power 4, 2y squared, 1 and 1 is out. We have a plus y, sorry, minus y, and we have a minus 2 root y. So root y, I'm going to write as y to the power half, because I'm going to integrate after this. So the volume is integral from 0 to 1. Take the pi out and integrate all of this. Just copy and paste here. dy. You got pi, y to the power 5 over 5 minus 2/3 y cubed
Mr.
minus
Again, it's
y
plus.
squared over 2, which is a plus.
Plus 2 over 3y cubed.
Plus 2 over 3y cubed, thank you.
No worries.
Minus y squared over 2 minus 2y to the power 3 over 2 divided by
Times
3
2
over
over
2 is
3.
times 2/3, times
Yeah.
2 over 3. 0 to 1. And it's nice to substitute 0 to 1 because when you substitute 0, all the y's cancel out. You got pi 1/5 plus 2/3 minus half minus 4 over 3. Correct? And just put all this in the calculator, you should get the answer. 1 over 5 plus,
And we get some
plus
negative
2/3
answer.
minus 2 the minus,
No, it
minus
can't be negative.
2/3
2.5
minus 2 over 3. There.
minus half.
1/5
Yeah, minus 2 over 3 minus half. I don't know how we're getting negative.
minus a half. We're getting negative 29 over 30. So let's check. Let's go back to our this thing. All right, so 1 plus y squared. I had root y.
Oh, Mr. It's because
Root y
it's
plus
because
1.
it's in the negative quadrant, right?
No, it's not that. The volumes should always be positive.
Oh, okay.
1 plus y squared and root y plus 1. That's correct. So the outer radius. See if the green function. What was the green function?
Mr.
That's the
Green
outer
function
one.
was y square x squared. Y equals x squared.
Ah, did I switch it around?
No, you did it fine. Y is equal to
y is equal to x
yeah, inner
squared.
function. Yeah, inner function is the
It's the other way around. So the inner function was y equals
oh,
x
you
squared,
flipped it.
isn't?
Yes, yes, yes. Yeah. So that means
Okay,
the
okay.
outer
Yes.
radius was yeah, okay.
Okay, so we flipped it up. Yeah, all right.
Yeah.
So this is supposed to be inner and outer. I messed up the
Yeah.
functions. All right. So
So
this
the
is
negative just gets removed, right? Or no, no, it
I'm not
doesn't.
sure. No, no, no. That it's going to
No, I
change the
don't
entire
think so.
function.
Yeah, yeah, yeah,
That's
yeah.
the inner. That's the outer.
Oh my God.
No, it's fine. There's not much changes. It's just squaring a
Yeah.
binomial. We'll check now. See how this functions change. So obviously, if you get negative answer, you know the answer is incorrect. So it's just squaring a binomial. So I'm going to put a plus here. See what I'm doing now? That should be a negative and that should be a positive. So inner, wait. Outer minus inner. What am I doing? Outer minus inner is correct. The formula was right. I just need to switch the bottom parts. Sorry, guys. Uh, why did I switch the functions around? Okay. All right, that's what we need to do. Switch it around. And then all of this will also switch around. We will come to the answer, right? We have to come to the answer. So this part here goes first. Okay. And obviously only this function here will change now. Okay. So 1 and 1 still cancels out. So you got 2y to the power half plus y minus 2y to the power 2 minus y to the power 4. So only these things changed. All the negatives became positives, right? So this one is a positive y squared. Yeah, this will be a positive and this will be a negative and that will be a negative. Negative here. In other words, there was a negative here and a negative here. So we fixed it up. Minus y to the power 4 minus 2y squared plus y plus 2y to the power half. So plus 2y to the power half is plus here, plus there, negative here, and negative here, right? Should work now. Negative 1/5. So it's going to be plus 2/3, right? Minus 2/3 plus 4/3 plus 2/3 plus half. Yeah, now we get a right answer. We get 29/30 pi. Are we good, guys?
Yep. Mm-hmm.
Right, and this brings
Wow.
us to the end of our lesson. Right, guys.